Hi students, good morning. Yesterday we have seen mathematical expression for work done during irreversible process. In that process, pressure was kept constant and the change occurred in a single step. Now we shall see mathematical expression for work done during isothermal and reversible process. And work done during isothermal reversible process, it is represented by W reversible or W max, maximum work, because work done in isothermal reversible process is always maximum. Why work is maximum, that we shall see even in detail later on. But during reversible process, as we know, opposing force is as much maximum as possible. Maximum force होता है opposing reversible process में, and as opposing force is maximum in reversible process, work done is also maximum. 2 points we shall keep in mind for this expression. Reversible process occurs in infinite number of steps. एक स्टेप में ये वर्क डन नहीं होगा, या जो भी चेंज होता है रिवर्सिबल में एक स्टेप में नहीं होगा. इट विल इन्वॉल्व infinite number of steps. Consider n moles of an ideal gas are taken in a cylinder at constant temperature T, because process is isothermal, and this cylinder is fitted with a weightless and frictionless piston. Now, external pressure P external, it will be equal to pressure of the gas plus minus dP. Now, why we do consider plus minus dP? देखो बेटा, if gas undergoes expansion reversibly, then external pressure should be infinitesimally smaller than pressure of the gas. So P external will be equal to pressure of gas minus dP for expansion. If gas undergoes compression, then external pressure will be infinitesimally greater than pressure of the gas, and for compression P external will be equal to pressure of gas plus dP. And external pressure and pressure of gas, they are related for reversible process by this expression. P external equals to P gas plus minus dP. dP stands for infinitesimally small amount of pressure. Okay. Now we know expression for work done W is equal to minus P external into delta V. Delta V is change in volume by large value. As reversible process occurs in infinite steps, we have to first of all find out or calculate work done in a single step. And for a single step, a very small amount, infinitesimally small amount of work is done, that is represented by dW, and it is equal to minus P external into dV. Instead of delta V, what we shall consider here? dV. dV stands for infinitesimally small change in volume. देखो बेटा, if gas undergoes expansion reversibly, then external pressure will be infinitesimally smaller than pressure of the gas, and during that change, piston will be shifted in upward direction by an infinitesimal small amount, say dl. यहाँ piston upward direction में बहुत small value से चली जाएगी, that distance is equal to say dl, and that's why corresponding infinitesimal small change in volume will be equal to say dv. और इस सिंगल स्टेप में जो भी वर्क डन होगा वो बहुत स्मॉल होगा, dw infinitesimally small, and it is equal to minus P external into dv. But we have just seen P external is P gas plus minus dv. Now, small amount of work done in one step for expansion, dw will be equal to minus P external plus minus dp complete bracket multiplied by dv. और अगर हम इसे सिंप्लीफाई करेंगे, इट इज माइनस P external into dV plus minus dP dV. What is dP dV? Infinitesimally small pressure and infinitesimally small volume. As both are infinitesimally smaller, their product dP dV will be still infinitesimally smaller. ये और भी small होगा, and this product dP dV, it can be neglected. dP dV ये product बहुत बहुत small होगा, and so it is negligible. So avoiding dP dV term, a small amount of work done dW will be equal to minus P external into dV. But दिस इज द वर्क डन इन अ सिंगल स्टेप, एक स्टेप में इतना वर्क डन होगा. That's why total work done during expansion when gas expands from initial volume V1 to final volume VT, that is equal to W reversible, and that is the summation or integration of all these dW terms or P external dV terms. देखो बेटा, अगर गैस रिवर्सिबल वे से रिवर्सिबली V1 से लेकर V2 तक एक्सपांड होता है तो हर एक स्टेप में जो भी वर्क डन होगा दैट इज इक्वल टू dW, लेकिन टोटल चेंज में जो वर्क डन होगा दैट इज समेशन यानी इंटीग्रेशन एडिशन, दैट विल बी एडिशन ऑफ ऑल सच dW terms, and that's why integrating this equation between the limits V1 to V2 we get total amount of work done, that is maximum work. So W reversible or W max is equal to integration of minus dW for the limits V1 to V2, and it is equal to integration for minus P external into dV. But we have ideal gas equation like PV equals to nRT. Ideal gas equation क्या होता है? PV equals to nRT पता है आपको ये, and that's why P is equal to nRT by V. Okay? Simplifying further we get W reversible equal to integration of minus nRT by V into dV between the limits V1 to V2. P is replaced by nRT by V. और अगर हम इसे सिंप्लीफाई करेंगे nRT it is a constant term, so it is equal to minus nRT integration between the limits V1 to V2 of dV by V. और एक स्टैंडर्ड फॉर्मूला इंटीग्रेशन का आपको भी पता होगा, इंटीग्रेशन ऑफ dV by V between the limits V1 to V2 it will be equal to natural log of V between the limits V1 to V2. और अगर हम इसे फिर सिंप्लीफाई करेंगे इक्वल्स टू माइनस nRT ln यानी नेचुरल लॉग, लॉग टू द बेस c, नेचुरल लॉग ऑफ V between these limits, लोअर लिमिट V1 अपर लिमिट V2. और अगर इसे हम सिंप्लीफाई करेंगे प्लेसिंग अपर लिमिट माइनस लोअर लिमिट वी गेट माइनस nRT natural log of V2 minus V1, and again we know log A minus log B is equal to log of A by B. हम थोड़ा शॉर्ट में लिखेंगे, so W reversible will be equal to minus nRT into natural log of V2 by V1. Again converting natural log to log to the base 10 we get W reversible equals to minus 2.303 nRT into log of V2 by V1. अगर हम नेचुरल लॉग को लॉग टू द बेस 10 में कन्वर्ट करते हैं तो एक्सप्रेशन या फॉर्मूला आपको पता होगा, इट इज टू बी मल्टीप्लाइड बाय 2.303, एंड दैट्स व्हाई वर्क डन ड्यूरिंग isothermal reversible process will be equal to total work done W reversible minus 2.303 into nRT into log of V2 by V1. This is the desired equation. N is number of moles of gas, R as usually universal या molar gas constant, and T is temperature. But according to Boyle's law, we know P1 V1 equals to P2 V2, and that's why V2 by V1 will be equal to P1 by P2, and replacing V2 by V1 by P1 by P2 we get another expression for W reversible. It is minus 2.303 nRT log to the base 10 P1 by P2. Okay, so this is mathematical expression for W reversible, W max, yeah, work done during isothermal and reversible process. Okay, now see beta, और एक सिंपल सा पॉइंट हम यहाँ कंसिडर करेंगे, फ्री एक्सपांशन ऑफ गैस या वर्क डन ड्यूरिंग एक्सपांशन और कंप्रेशन ड्यूरिंग एक्सपांशन ऑफ गैस इन वैक्यूम. वैक्यूम where opposing pressure is 0. We know expression for work done W is equal to minus P external into delta V, but यहाँ opposing pressure is 0 as expansion occurs in vacuum, work done will be equal to 0, and hence we can say no work is done during expansion of gas in vacuum. गैस अगर वैक्यूम में एक्सपांड होता है तो वर्क डन विल बी जीरो या नो वर्क इज डन बिकॉज या अपोजिंग प्रेशर इटसेल्फ इज जीरो. सो लेट मी इंट्रोड्यूस यू विथ वन मोर फंक्शन दैट इज पाथ फंक्शन. इसके पहले हमने इंटरनल एनर्जी, एंथैल्पी एटसेट्रा दे आर सीन टू बी स्टेट फंक्शंस. स्टेट फंक्शन क्या होता है बेटा? इट्स वैल्यू डिपेंड्स अपॉन ओनली इनिशियल एंड फाइनल स्टेट्स ऑफ द सिस्टम एंड नॉट अपॉन द पाथ. But what is path function? Path function is such a function, such a property whose value depends upon path followed and not upon initial and final states. यहाँ initial final states कोई भी रहने दो. Which path is followed to bring about that change? उस पे अगर value depend होती है तो that is known as path function. A property whose value depends upon path followed and work done, you will always find it is a path function. And why it is path function? हमें पता है वर्क डन इन इरिवर्सिबल प्रोसेस एक्सप्रेशन होता है माइनस पी एक्सटर्नल इंटू डेल्टा वी. ए एक्सप्रेशन होगा. इरिवर्सिबल प्रोसेस में जो भी वर्क डन होगा दैट विल डिपेंड अपॉन डेल्टा वी. वही चेंज v1 v2 वैल्यू ऑफ डेल्टा वी वही रखेंगे, लेकिन अगर वो चेंज रिवर्सिबल मैनर से कैरी करेंगे तो उसके लिए एक्सप्रेशन आएगा -2.303 nRT log v2 by v1. It is different than that for irreversible process. Irreversible process के लिए अलग एक्सप्रेशन, रिवर्सिबल के लिए अलग. और उतना ही अगर वॉल्यूम चेंज हम कैरी करेंगे बट इन वैक्यूम तो वर्क डन इन दिस केस विल बी जीरो. नो वर्क इज डन. यानी वर्क डन doesn't depend upon initial and final states only, but it depends upon path followed. Irreversibly वो चेंज होता है, रिवर्सिबली होता है या वैक्यूम में वो चेंज होता है. And in this way, work done depends upon path, and that's why it is known to be a path function. और हमेशा ये क्वेश्चन होता है select the odd man out या which of the following is state function, path function. उसमें ध्यान रखिएगा work, heat and heat capacity. These are three path functions. Heat, work and heat capacity. ये तीन कौन से functions होते हैं? Path function, because their changes depend upon path followed, not only initial and final states. Got it?